So let's look at 13C. And here we're going to make use of a couple things. One is the power sum formulas. So I talk about these in the lecture videos. So here's two of them that we're going to use in this particular problem. And you don't have to have these summation formulas memorized. A lot of you will have this first one here memorized. This is as really the sum I equal 1 to n of I is just what, 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way up to n. So it's the sum of the first n numbers. And this is the solution to that sum. It's really whatever n is times 1 more than n divided by 2. Now, there's this form here, and this is the form I'm actually going to use for these problems. Now, later on, I like to use these sort of expanded. If I distribute the n through, I get n squared plus n up top, and then break up the fraction into two parts, n squared over 2 plus n divided by 2, right? I could do that because I have the same denominator. So this over here is the same thing, but I'll use this a lot of times when we're doing the R sub n problems later. But for this problem, I'm going to use this because n in this problem is given as a fixed number. So it's just easier to use this version. The sum of the first n squares, so this would be 1 squared plus 2 squared plus 3 squared plus 4 squared and so on, is equal to this big expression. This is a 2 right here, sorry. I don't know what happened there. That's a 2n plus 1, sorry. N times n plus 1 times 2n plus 1 all divided by 6, which if you expand out this top and then rewrite over individual fractions, this is what it looks like. And this is what I'll use again later on when we do the R sub n, but this is what we'll use now. So again, you don't have to memorize these. These will be given on the test for you. In addition, though, you will need to know the linearity rules for sums. These won't be given on the test, and this simply says the summation of any constant times an expression, if that's dependent upon your index I, you can sort of pull that constant outside the summation. And another one I should say is that sort of says if I sum I equal 1 to n of just a constant, we saw this before, this is just n times that constant. So really you can bring that constant out, and then you're just doing 1 plus 2 plus 3 plus 4. Sorry, you're doing 1 plus 1 plus 1 plus 1 plus 1 n times. And then so you would do n times whatever that constant that you pulled out was. That's how you're getting n times c. The other linearity rule is the summation I equal 1 to n of a sub I plus b sub I is, right, the summation I equals 1 to n of a sub I plus the summation I equal 1 to n b sub I. We can break it up into two sums. So that's the linearity rules that you'll need to know. So let's see how these are used in this expression for number 13, part C. Okay. So first of all, I'm going to make use of this bottom linearity rule by breaking up this into the sum of 2. So I've got summation I equal 1 to 14 of 3i squared plus the summation I equal 1 to 14 of just I. So that's making use of this. And then this 3 here is a constant multiple, making use of this property. I can pull that 3 outside the summation. I can't pull the I squared outside, right, because that is dependent upon the index I. And now I use the power sums. So this first one here, I use this power sum up here. I'm just going to simply replace this expression here, but I'm going to replace n with 14, right? So I'm going to have 14 plus 1 is 15, and then 2 times 14 is 28 plus 1 is 29. 14 times 15 times 29. And that's what I have here, 14 times 15 times 29 before I simplify, all divided by 6. So don't forget the 3's out here. And then the summation I equal 1 to 14 of I, well, I'm going to use this one up here, and I'm just going to replace n with 14, right? So it's going to be 14. 14 plus 1 is 15, so 14 times 15 divided by 2. 14 times 15 divided by 2. Now you can use your calculator, just plug in as is and get the answer, but I do a little simplifying. So notice the 3 divides into the 6 twice, so I can divide top and bottom by 3, sort of cancel the factor of 3 from the numerator and denominator. And then when I have this 14, I can divide 14 rather divided by 2 is 7. And so I'm just left with 7 up top. So 7 times 15 times 29 is how this simplifies. And here I can divide top and bottom by 2, and I get 7 times 15. So it just simplifies it a little bit. At any rate, when you do that calculation there, you get 3,150, and that's the actual sum that we get in this case. So this is just getting you used to power sum formulas and the linearity rules. Later, when we do R sub n, it's not going to be as easy in one sense, because the value of n is going to be n. It's not going to be 14 like it is in this example, or any fixed value. So we'll look at some of those here shortly.